From the technological developments and advances in the area of robotics, the use of autonomous robots has become increasingly broad, improving performance in several areas. The implementation of a project in the subject Unified Engineering 2, contemplating the knowledge of different areas of engineering, and aiming at the elaboration of a project that includes concepts of mechanics, electronics, and programming, demonstrates the capacity to which simple daily tasks can be made from the application of autonomous robots. In this project, the robot must be able to balance itself on two wheels, whereas tracking a circle. Furthermore, we propose the following challenges: carrying additional weight and moving on an inclined surface. Based on the proposed challenge, this project will be executed using the parts contained in the LEGO Mindstorms NXT kit, as well as an MPU 6050, and control principles based on the concepts of PID, Proportional Integral Derivative Control. PID controls allows a stable system operation with a precise control, based on desired set point, regardless of disturbances or variations to which the system might be exposed. Using the available LEGO Mindstorms NXT kit, the robot was built to realize the requirements in the simplest way possible. With this objective in mind, we made use of LEGO Mindstorms NXT Intelligent Brick as the basic structure with two motors coupled to its sides. The motors' positions were changed throughout the project, as of to adapt to the robot's center of mass, allowing the robot to perform a better position control, that is, a better equilibrium position. On top of the robot, a structure was built in order to place an external sensor to the kit, the MPU 6050. Due to inaccuracies in LEGO's gyroscope, we suggested the application of MPU 6050 sensor to detect the robot's inclination. Also, we decided to take advantage of breakout board GY521, which contains a voltage regulator besides the sensor. The pull-up resistors in this board do not possess the appropriate values to be compatible with the LEGO kit. Hence, we added an additional circuit with resistors of adequate values, a diode for the protection of the circuit, and a LED to check the connections in the circuit. It's worth pointing out that we had to adapt the RJ12 connector, removing its lock so as to connect the electrical circuit to the LEGO kit. In order to maintain the robot's upright equilibrium, a PID controller was implemented. This control technique takes into account the error in position, that is, the difference between the desired position and the actual position, its time variation and its values before. The program was written in the NXC language via the Bricks Command Center platform. Firstly, we defined the port into which the sensor is connected and its address in the I2C serial computer bus. Moreover, we determined the addresses of the Power Management 1 register and of the register for reading of the X-axis from the gyroscope. Here, we choose constants for the starting and reading of the gyroscope, and offset, the PID control constants, and the power limit for the motor. In this part, the necessary variables to make the code work are defined. Now, we perform the starting of the gyroscope, as described in the datasheet. In this step, the reading of the gyroscope is performed, then this value is divided by 100 for better data manipulation. In the highlighted items, angular velocities numeric integration is done, so as to obtain angular position. In this section, numeric integration is carried for use in the integral component of the PID control. In this line, we determine the PID control. Notice that division by -1000 is necessary to get values compatible with those accepted by the motors. Here, the power of the first motor is limited, according to what was previously defined. Now, the second motor's power is increased in 50%, so that the robot will track a circle. In this section, a similar procedure is employed to restrain the second motor's power. In the end, the calculated values are applied to the motors. Using a PID control, it was possible to attain the objectives in this project, besides the additional challenges. In order to achieve the desired result, we had to test different constants for the PID control, so as to guarantee the robot's stability. After various experimental adjustments, we were able to keep the robot in the upright position while tracking a circle.